Welcome back. So this is part 2 of my PyGame series. This is Tutor Edward Lee, both speaking, recording, producing, and so on. Also uploading later, hopefully. But in the first video, we got colors. We got colors! That's it, we got colors. Yeah, I got color on my background, and I played with it, and you can actually still see the aftermath of all that over there on the left side of my screen. I erased all that code. If you're curious what I did there, go check that video first. I found a good background color that I want to use using an RGB color picker. Again, you can literally just Google RGB color picker and a neat little utility shows up. But there we are. It's a nice soft blue. I like it. And so I just entered that. And again, this is the same basic code that I use every time I write a PyGame program. Always. Boom. I start off with this. In today's lesson, what I want to do is I want to create rectangle objects. I'm going to pull something up really quickly. This is the PyGame documentation. It's really helpful. I've told my students to, or I often tell my students to check to see if, or to write a program that checks to see if two rectangles that are moving randomly about a screen or about a window, which I haven't done in this tutorial yet, so don't worry, that's where we're going. If you're not familiar, if that sounds like a lot, don't worry, that's what we're doing in this video. To check to see if two rectangles bouncing around can or have if they've collided. And I show them a complicated way of doing it, but there's actually an easier way. There's a method or a function called collideRect. So normally the documentation will help you. It's here to help. Pygame.rect is everything having to do with rectangles. They also have color, display, draw. There's a whole lot of information here. Knowing when to use it is one thing, but at least knowing it's out there is normally a big step forward for my students. So I'm going to go ahead and I'm going to, let's see, I want to start off just by drawing a rectangle. The way that we do that is actually kind of straightforward. Pygame.draw.rect, and then it takes 3 arguments. It takes a screen. Normally it pops up there it is. It takes a surface, which is this thing right here, line 12. Pygame.display.setMode returns a surface, so I'm going to pass through win, and then a color, and then a rectangle object. So win, and then I'm going to pass through a color. Let's just make the color black for now. And then the rectangle object, you can define a rectangle object just like this, just by using an x, a y, a width, and a height variable, just like that. This is a tuple form. It's a type of a list. So the x and y are the top left corner. So if I want mine to stop at the top left of the screen, that'd be 0, 0, and then 10 pixels by 10 pixels. Let's see what that looks like. Looks like it didn't show. I wonder why. Well, there's a pretty straightforward explanation. Whenever I run my code, right before I refresh, right before I update the screen, I fill the background with the background color. So I need this line of code, the rectangle, to come after that. That's literally it. That is the only reason why it didn't draw. Boom, there it is. There's my tiny little rectangle up there. There it is. Let's make that rectangle a little bit bigger. Let's run it. Boom, that's way bigger. Let's make it move. So that's the next thing. There's actually a function for making it move. Pygame.rect.move turns a new rectangle that is moved by the given offset. The offset being obviously, or I suppose, this xy argument. So they can be any integer value. So what that supposes, though, is that supposes that you already have a rectangle object. And I normally don't create rectangles with my students. Instead, we just use numbers and keep track of them ourselves. So the rect object has several virtual attributes which can be used to move and align the rect. These are all really helpful, but I think it's more important to keep track of just 4 things: the x, the y, the width, the height, and then I don't know how many things I said we need to keep track of, but the velocity is also important, and so we're going to add velocity. This is where I'll sort of stray from the documentation. So normally what I do is, instead of creating a rectangle in this statement like this, I'll create a rectangle object of my own. I'm just going to call it rect right there. I'll create it up above So I still need the drawing to be down here after you fill, the background, but I'm going to create my objects up here. So create objects here. So rectangle is an object. So I'm going to say rect equals, and now I'm going to create a rectangle. And so remember the rectangle is x, y, height, width. If I just put like 20, 20, 50, 50, that's going to be, 20, 20 for the x, y coordinate, and then 50, 50 for height and width. But I don't want to do that because that's going to be static. What I'd rather do is I'd rather put x comma y, so that I can change the x and y values. So I'm going to have to declare x and y up above. So x, let's say position values for the rect object. So x equals 20 to start, y equals 20 to start as it was before. But what I'll do is move the rectangle. So what I'll do is every time I'll just increment, boom, just like that. That's it. That's literally it. That's all I have to do is x plus equals 1. That means the x value is going to be changing, and then I redraw the rectangle every time I recreate the object. Boom, just like that. I recreate the rectangle object every time. So, it's 20, then it's 21, then it's 22, then it's 23, and so on. And so that's how you get it to move. I want to point out that if I comment out line 34, this happens. Oh, sorry. That's actually not exactly what I wanted to show here. I need to do something else really quickly. Sorry. Okay. One more try. One more try, one more try, one more try. Boom, there we are. Okay, that's what I wanted to show. See, so it looks like it's like a loading bar. Basically, it's still doing the exact same thing, but it's not erasing all of the old rectangles that I drew. So it's creating new rectangle objects and drawing each of these new rectangle objects. And so that's why I have on line 35 the win.fill, because I want to fill the background with a new color every time. I'm basically erasing the screen and then redrawing a rectangle slightly to the right. And so, if I'm doing that every 25 milliseconds, which is what that line of code does on line 22, if I'm doing it every 25 milliseconds, then boom, there we have it. I'm animating. It's kind of like stop motion. So that's the basics of making the rectangle move. Once it goes off screen, it goes off screen though. I can make it go a little bit faster. We'll make it move by 2. But once it goes off screen, it goes off screen. So we can like create boundaries, move the rectangle within boundaries. Obviously, we don't want to get it. We don't want it to go too far to the right. The width of the screen is defined as win width. So I'm going to say if here I actually want to create a velocity variable. So name it xval equal 2, and then I'm going to make it so that it's x plus equals xval. There we are. Same thing, if you saw my previous color video, when I make the colors go up and down, back and forth like that, or like I did, then you'll notice that like I need to basically make sure it's not going too far to the right, too far past 255 and too far past 0. And what I'm going to do is I make the velocity value, how much it's changing by, I make it negative so that it goes the opposite once it recognizes a boundary. So if x plus xval, so before I add it, I check to see if adding the velocity to the x value, if it's ever going to be greater than 255, then win width, and actually I want to do more than that. X is the top left, so I actually want to do x plus 50, which is the width of the, you can see right there, it's the width of the rectangle. So I want to see if the right corner plus the velocity is ever going to be greater than the width of the window. Then I want you to go ahead and automatically make xval equal to negative xval. Switch the direction. Same thing, opposite direction. Elif x, and now it is the left, that's the top left, the x, so that's exactly what I want. If x plus xval, obviously that would be like a negative 2 value, but if x plus a negative xval is ever going to be less than 0, then I want to make xval equal to negative xval. Same thing. And then that's it. That's all I want to do. And then no matter what, I'm always going to keep adding it so that it keeps moving just like I want it to. Let's see if that works. It's still moving very slowly. And boom, it bounces. Just what I'm looking for. That's perfect. Whoop. So, you can go ahead and make this change. You can write your own code, and I encourage you to do it. In the next video, I'm going to assume that you already have on your own, but you can add basically the exact same thing for the y, and you can make it so that the first time the rectangle bounces, it randomly chooses a y velocity and then goes off in a random direction. And that's, what I normally do with my students. So at the beginning of the next video, I'm going to assume that you can do that.